Hi everyone. This video is going to introduce you to functions. In the first part, we're going to look at function notation. In the second part, we're going to define what a function is. So we're going to take a look at three different ways to look at a function: a table, a graph, and an equation. And we're going to find two things for each of those forms. So the first one says f parentheses 2. What this actually says is f of 2. Okay, so this is function notation, and there are two things you need to know about function notation. The f tells you what function you're looking for. So I like to call this the name of the function. Okay, so if it's f of 2, you're looking at the function f. If it's g of 2, you're looking at the function g. It's just a name. And whatever's in the parentheses is your input, or what you're plugging into the function. So put that together, what this notation really means is evaluate the function f at 2. At 2 is its input. And we're going to do that for a table, graph, and an equation. But I think the easiest one and the most familiar would be equations. So we're going to start there to figure out what the meaning of this is. So if I'm asked to find f of 2, notice how the 2 replaces the x here. So this guy says f of x, and this says f of 2. And that tells you exactly what you're going to do is you're going to replace anything with an x with a 2. Because like I said, 2 is the input. And if it's an input in the function, it means you plug it into the function. So if I want to find f of 2, I would plug in 2 for x. So it'd be 2 minus 2 squared minus 6, which is 0 squared. 0 squared is 0, minus 6, and 0 minus 6 is negative 6. Okay, so for part 3, we would say f of 2 equals negative 6, which essentially means that 2 again is the input, what you plug in. If it's an equation on a graph, we typically call that x, and negative 6 is the output. You might have seen those function machines back in the day. You plug something in, something comes out. That's exactly what you're doing here. Okay, so this would be the proper notation to state your answer. It's a little bit different if you're looking at a table or a graph, but it's got the same idea. So 2 is your input. We are looking for your output. Okay, now just like you replaced anything with an x with 2 here, we can think about this similarly with the table. So let's go back to number 1. So if I want to find f of 2 on this function, it's really asking where is x2. Okay, so here's where x is 2, and I want to find the output. So if my input is 2, my output would be 7. Okay, so on the table, it's telling me that f of 2 is 7. Okay, I want to just remind you again that that f just states the name of the function, which is why you would see the f in each of these things, as it tells you you're working with a function named f. Okay, last one is from the graph. So we want to find f of 2 on this graph. F of 2 again, 2 is your input, so that really means where is x2? So I'm going to find 2 on the x-axis. So this guy's my x-axis here. Here's 2. What is my output when x is 2? Well, this point is 2, 0. So if I plug in 2 for x, 0 is my output. So here, f of 2 would equal 0. So notation-wise, f is the name of the function, 2 is the input, pretty straightforward. Okay. On the other hand, you can also use the function notation to find outputs. So what this really asks is, what is x when again, this is the output. What is x when the output is negative 5? Okay, so we're going to do the same thing for the table, graph, and equation, but we kind of have to work backwards. And I actually think that the table is the easiest for this one, so we'll just go in order this time. Okay, so what this problem says is where is the output? Where is f of x negative 5? So I'm going to look at the f of x column and find negative 5. So that would mean your output is negative 5. And what's the corresponding input? What's the corresponding x value? You're finding x. So in this case, you would say x is negative 6. Or you can say f of negative 6 is negative 5. Okay, let's look at number 2 here. I'm going to erase the old one. In this case, you're trying to find where f of x is negative 5. Okay, so with that said, our input, as you've kind of noticed, is our x value. Our output is our y value. So really another way you can think about this, f of x is another way of saying y. Y equals negative 5. Right? Instead of writing f of x equals x minus 2 squared minus 6, I could say y equals this. Okay. So really what I'm asking is, where is y negative 5? So I'm going to go on my y-axis, find negative 5, and see what my x values are, which in this case actually happens at 2 different places, here and here. Okay, so at this point is -2, -5, and this point is 1, -5. So really 2 places where your output is -5, output meaning your y values. So you can say x is -2 and 1, or you can say f is 1, or f of 1 is -5, and f of -2 is also -5. For your last one, you're saying f of x is -5. I need to substitute -5 in where I see f of x. So really you'd have -5 equals the equation. And I'm actually going to come down and write this over here. -5 equals x minus 2 squared minus 6. And this is an equation you need to solve. So when you solve an equation, you're going to try and isolate the variable. So first thing I want to do is move the 6 over. Okay, so add those together, you get 1 equals x minus 2 squared. Now that x is kind of trapped inside this squared, so I need to think, how do I undo a square? Okay, the answer to that is you take a square root. Okay, so square root of 1 is just 1. Square root of x minus 2 squared is just x minus 2. Okay, now I'm going to pause for a second and think about this equation, which has nothing to do with the current equation, but it's going to help us realize something. If I said x squared equals 9, and you were solving this, what could you plug in for x as your solutions? Most people would say x is 3. But in reality, there's actually 2 solutions, because if you square -3, it also gives you 9. Okay, so if you wanted to solve this and you didn't just know off the top of your head what squared equals 9, you would take the square root of both sides, and most people would try and say 3, but really you need plus or minus 3. Which when I say that the square root of 1 is 1, technically can be plus or minus 1. Okay, so it could be x minus 2 equals 1 or x minus 2 equals -1. With that said, I got to isolate x now that it's kind of almost by itself. Add 2 to both sides. You get x is 2 plus or minus 1. So 2 plus 1 is 3. 2 minus 1 is 1. And there can actually be 2 x values where your output would be -5, which would kind of be like this graph here, right? There are 2 different x values that correspond to y. And we should have an idea of what this equation looks like. If it's a squared, it's some sort of parabola. I don't know exactly where it is, but at -5, it might have those 2 x values. That's why you have 2 answers. Oftentimes people forget the plus or minus, which is why we lose an answer. Okay, so with that said, that's function notation. Whatever's in the parentheses is your input, whatever it's equal to is your output. So it's kind of like saying f of x, f of 2 means x is 2. Okay, f of x is kind of like saying y. So really, again, I don't need to rewrite that. Y is -5 is what that's saying. Okay, so that's all about interpreting. Remember, f is a function name, and you can extend your knowledge into problems such as the challenge down here. Okay, so I'm taking the same function, but I'm finding different things. So if I say f of a, all this means is a is your input into the function. Input means it's what you plug into the function. So if I want to find f of a, you're replacing that x with an a. You should replace every x with an a. So f of a would be a minus 2 squared minus 6. I should probably write this again. And that's all that's asking for. Okay, I'm going to pause the video, and I want you to try 2 and 3 on your own. 2 being a little bit of a step up, and then 3 being a little bit more challenging to look at. And then I'll come back with the answer. Okay, so you should have tried these on your own, and this is what you would get. So if I say f of x plus 2, all that means is take x plus 2 as your input and substitute it in for your old input. So our old input was x, and where you see an x, you'd substitute x plus 2. So here's my work. This used to be an x, now it's an x plus 2, but I have an x plus 2 minus 2 that cancels to give me x squared minus 6, which is what you see here. Now this just says take f of x plus 2 and divide it by f of a. This is what we got for part 2. This is what we got for part 1. You're just dividing them. You can't simplify them because we have x's and a's, and there's nothing that can be done there. Technically, I guess you could expand this, but why waste our time? So that's all that's asking for. What I'm trying to instill here is that whether this is a number or variable or an expression or whatever it is, all that means is the input. So take that and substitute in the function f. That's our name. Okay, so that's function notation. Please come with questions and have a great rest of your day.